Welcome back to the classroom. My name is Mr. Wong, and today we'll be looking at the 2017 Victorian Physics paper, question 12. This is going to be about collisions if we try and align it to the New South Wales syllabus that matches Module 2, inquiry question number 3. So let's have a look at what this question is asking about, and let's see how we can try and solve for it. So just quickly going into the question here, it's asking us to determine using calculations whether our collision is elastic or inelastic. We need to show our working and justify our answer. Now, from this diagram here, if you so recall, when we're talking about elastic or inelastic collisions, we're talking about whether or not kinetic energy is conserved. Okay, so if it is an elastic collision, kinetic energy before is equal to the kinetic energy after. If it is inelastic, then that relationship should not equal. Okay, so that's what we can say about this particular relationship here. Now, one way we can look at it in terms of diagram, whether or not a elastic or inelastic collision has occurred, is whether or not the actual structure combines with each other. If it has combined, as you can see here, that is a demonstration that it's most likely an inelastic collision. If it's totally elastic, it should bounce off each other. So at least we know it should be inelastic, but let's prove that using the calculations. So we have a student with two trolleys. Trolley A has a mass of 4 kilograms. Trolley B has a mass of 2 kilograms. And they were investigating their kinetic energy and momentum. Before the collision, Trolley A is moved to the right at 5 meters per second. Trolley B is moving right at 2 meters per second. So they're both moving in the same direction before they lock onto each other. Let's say that going right is the positive direction. Let's actually have a look at what happens here. Okay, so we know, according to the formula for kinetic energy, so what's before equals to what kinetic energy after. I'll just scroll down a little bit more. This is half ma for block A, u for its initial velocity, plus half mb ub squared equals to half m of A plus B, because they've now combined together, and then v squared, their final velocity there. Okay, so as shown, the trolleys collide and lock together. That's what they have. From the looks of it, we actually need to find the final velocity first, okay, of AB before we can actually work out if this is elastic or inelastic. So this is the formula that we have originally, but I'm going to have to quickly rub this off because I need to do the momentum formula to find the final velocity. Okay, so using the momentum formula, we can try and write the same thing. mu A plus that B ub equals to ma plus b v. Okay, so m is 4, ua is plus 5 plus m, which is 2, times by positive 2, and then the mass that we have combined is 6v. If I rearrange the equation around, okay, so add it all together and then divide by 6, let's see what we get. Just write it on this side, so I had 24 on this side and then 6v, so 24 divided by 6, and the velocity is positive 4 meters per second, which also implies that this object is going to move to right after collision. Now we can try and do our conservation of kinetic energy and see whether or not kinetic energy is properly conserved. Okay, so what we talked about was we're now going to use the kinetic energy formula. So half MAUA squared B squared equals to half M plus B and then V squared. Okay, do remember to square the values at the end in your calculator. That tends to be some reasonings where people can muck up their calculations, so just be careful with that. So there's that. Obviously in this case it doesn't really matter if I'm dealing with a positive or negative V, because when you square it, it becomes positive anyways. And we have 6, and then this becomes 4 squared. Now remember what we said, in order for this to be elastic, the kinetic energies should be equal to each other, and if it's inelastic, they should not equal to each other. So let's have a look. So on the left hand side we have 54 joules, and on the right hand side we have 48 joules of energy, so they are not equal. So as the left hand side does not equal to the right hand side, collision is inelastic, kinetic energy is not conserved. And that's how you approach this question. So obviously this is looking at conservation of momentum, as we saw at the top here, and then we looked at conservation of kinetic energy. Now remember, conservation of momentum always occurs in any type of collision, whether it is elastic or inelastic, but only, and this is only for elastic collisions, is kinetic energy conserved. Inelastic collisions do not conserve kinetic energy. Okay, so that's how you do that. If you found this video useful, please hit the like and subscribe, and I'll see you next time.